Okay, so artificial gravity. What is it? How do we create it? So if we're thinking about this. Um, the first thing I'm going to do is look at what other people have thought of before. So, um, with creating artificial gravity, the basic idea is they have to create some sort of acceleration, and that acceleration and gravity are very similar, but they're not the same. But you can approximate gravity by accelerating yourself. So you could sit on a spacecraft, for example, that's accelerating at you get accelerating at the correct speed, and as long as you're constantly accelerating, it'll feel as if you have one gravity on you, just as you feel it when you're on Earth. Um, and so to build a craft that can do that is quite impractical. The amount of fuel and whatnot to be able to maintain a 1g acceleration is quite tremendous. So that's a cool idea. Um, Now the other idea is um, to use some sort of spinning craft, and so with the idea you take advantage of the fact that you can like hold water in a bucket and you can take it and spin it around, um, spin it around your arm, and it'll stay in the bucket because the acceleration you're putting into it as it's going around the circle ends up keeping it in the bucket. Um, and so you can take advantage of this um, to potentially build like a space station that could supply you with gravity while you're in space. But the problem with this is that um, you don't really get, like, you can calculate the speed and everything you need to spin it, but you don't get the full gravity like we experience on Earth. You get a gradient of gravity where, and on the outside of whatever you're spinning, so this would be where you're walking, um, where your feet are, that ends up being having the highest amount of gravity, and then where your head is has a lower amount of gravity simply because of the acceleration. So, and I think there's been different tests and whatnot building like small um, things that spin around like this, and people that go inside they experience dizziness and whatnot because of this difference in gravity. And so um, one of the ways you can fix this is by scaling it up, making it really, really, really big, so that the gradient you have from your head to your toes is much, much smaller. But then the problem with that is that in order to the size of the craft, you have to make it so large. The amount of like rocket launches to get to space um, becomes so high, and we don't even know how to build something that big in space. Um, so there's one thing I've posted about on the Space Stock Exchange, which is a different um, design for one of these crafts, because whenever you see them proposed, they say you have to build like sort of a ring. So they say they're going to build a ring around, and then that rotates, and that gives you that spins. You get some sort of central point that spins around, and then this gives you your artificial gravity place where I can walk around. But then, like, how you build a big structure like this, and so in some proposals are you take like a tether. Instead of building the whole thing, you just build one segment of it, and then that rotates around a central point. But tethers, um, tethers are something I think should be you need to like delete from your brain when you're engineering things in space, because tethers, like, there's a good documentary that demonstrates this where the guy is a tightrope walker, and he walks across the twin towers when they were still around, and he goes into how, like, when you have these tether systems, the because he's a tightrope is basically the same thing. Um, it's really tricky to walk on because of all the different ways that the tether moves. It can roll this way, it bounces up and down this way, it sways back and forth this way, and all of these movements you have to watch for and balance for against as you're walking across. And so uh, the same is true if you're engineering something that relies on the weight of a tether. You're gonna have the same sort of problems where you got to compensate for the fact that it's got to twist and shear and do all of these other movements. And so using tethers, I think, for anything load bearing in space is a bad idea. But for using it for like a backup thing, like when you're on a spacewalk, it kind of makes sense to have a tether so you don't fall away from the space station or your spacecraft. But like in that case, you don't have to rely on the tether being straight and rigid. That's um, because it's just an emergency thing, right? It's not important that it stay completely straight and rigid. Where if you're trying to build a space station that goes like this, and you're trying to do it based off of tether, you're gonna have all of these problems to deal with, because like in space everything is just constantly moving. You can't, like, you're moving, and yeah, there's so much movement going around that tethers, I don't think, make sense in space. But and so like I have a proposal where instead of building something like this, you build things like this, and then you just attach a bunch of essentially just empty rockets, and we already know how to do this. We already know how to do this construction technique, because that's how space stations are built. With uh, they'll launch like a tube, and then launch another tube, and then fly them close to each other, and then mate them together. The only difference is you're just mating them this way. So um, that would be kind of cool. But again, it's because of how big you have to make a spacecraft like this, and the amount of launches and everything, it's quite expensive, hard to justify. So it's a cool means to get artificial gravity. But is there any other way? Is there anything like in the sci-fi movies where they just like have their spacecraft that basically just looks like an airplane, and they're um, can just stand up and they're in space and they can accelerate and cruise around um, without feeling the effects of the acceleration. Um, so would something like that be possible? Now, what's interesting is if you were to engineer a system like that, you actually need to have two. Um, you need to have two artificial gravity systems. You need one for the outside of your craft for your propulsion, and then you need one on the inside of your craft to keep you um, from getting sloshed around and hitting the side of the vehicle and squishing. So, um, and the two systems have to be probably similar in technology, but slightly different because of um, how they have to interact with each other. And like you can imagine, like maybe if you had something like this on a rocket, and you're launching into space, well, the rocket is going at like say like 5 G's acceleration, and that's the outside, right? It's providing the acceleration that way. Then on the inside, you have to have -4 G's acceleration being applied to you so that it cancels out with the 5 G's of acceleration from the craft, so that you feel 1 G. And then, like any time you move around and whatnot, you have to do the adjustments so that you can still feel like you're not moving. Um, So, like, what a system could you even build a system like this? What would it look like? So, is if you like take the problem of just like just moving something, accelerating, and lifting up off the ground. Um, okay, no. All right, we're still describing what has been done. And so that's sort of one branch of artificial gravity research that we've seen is um, basically creating big, impractical spacecraft that can um, provide you the effects of gravity on them somehow. And so another um, sort of branch of artificial gravity research is through using the air. So they have these um, chambers that you can go into where they have a bunch of air blowing up into them, and they call them like anti-gravity chambers or whatever. And you can go into them and fly around. Now, what's interesting about this is this kind of gives us a framework for how we can talk about different types of artificial gravity systems and what they can and their advantages and disadvantages. So I'm not sure if they do this at these types of facilities, but you should be able to just have like a moonwalk scenario or a Mars walk scenario where you have the column of air controlled in such a way that you could be on the ceiling and experiencing like 1/3 or 1/6 gravity and walk around and bounce around and see what that feels like. Which would be kind of fun, but kind of fun. Um, right, so this gives us a framework to think about how to describe advantages and disadvantages. So, um, okay, so the wind is actually kind of a valid way to generate gravity. You can imagine maybe a simpler way to think of this is maybe a vacuum cleaner, sucking air in, and then you have a grate on top, and you can stand on top, and now you're sort of stuck like artificially gravity wise to this grate on the vacuum cleaner, um, and so the problem with this is that um, while the outside of my body will feel right, so maybe we'll just go back to the cool chamber that you can go and fly around in. And if I'm like stuck to the ceiling, like my body is going to feel like it's stuck to the ceiling, but internally my organs are still going to be feeling the effects of gravity, and the blood's all going to be rushing to my head and whatnot. Um, and so you can imagine if you had like a cup of water in this scenario, for one, the water would probably just go everywhere because it would get blown out of the cup. But if you had a bottle of water, then the bottle of water could be, you could set it on, right? You can set it on the floor. You can hold it in your outstretched hand, and it could sit because of the air pushing it down. But again, the internal part of it is still going to be overcome by the whatever gravity plane you're in. And so ideally in an artificial gravity system, you want to be able to affect both. You want to not only be able to affect the outside of the thing to be able to put it where you want to be able to affect the inside of it as well to be able to make the fluids and whatnot sit in the right spot. And this is why, living in space right now is uncomfortable and whatnot because there is no gravity, and so you don't get the circulation to your body properly, and so yeah. So if we're designing an artificial gravity system, that's different ways you can sort of classify them as whether or not it just holds the object down, or whether or not um, like the water in the water bottle is going to be stuck to the bottom or not. The sort of water bottle problem. Um, and ideally, you're right, we want to be able to affect both. Um, so that's interesting. If we look back at the other systems that we have, the one that spins around, this gives you what you want. It'll affect your internals as well as your external gravity. Um, but again, like the air one, it affects the outside but not the inside. So, like if you were in space, for example, you could maybe use it um, to give you the ability so you could walk around your spacecraft without having to bump into things, but you're still going to feel as if all of the fluid in your body is clenched up and in the middle of you, um, like the astronauts feel on the space station right now. So could you even build a system that's able to provide that acceleration you need to keep you grounded without having something big? Like we can do this like artificial trick with acceleration, but the thing's not to be so big, or we could we could bring Earth. You can bring Earth along, but Earth is so big. Um, so is there a way that we can trick our way out of it here? So, um, so one pattern to look for is um, things that are able to provide acceleration in one direction. Um, and so, like we see with the other example with rockets, or make a big rocket that can accelerate at 1g. But we also have other examples of things that are able to sort of accelerate in one direction. So we have like the putt-putt boat, and um, so with that thing there, you run it off a candle, and the candle heats up the water, converts it into steam, and it's able to create a cycle where overall, even though you're just basically exchanging um, the fluid back and forth, overall you end up exchanging more, so you end up accelerating forward. Um, there's another example of this. There's an app you can get for your phone that produces a sound which you can use as a little blower to blow around like dust and whatnot. And so it's able to create a vibration. It's able to like the speaker can only move back and forth, but you can vibrate it in such a way so that overall it's able to push the air more forward, right? And so it seems like through vibration and by sound is the way to, it's a potential way to create artificial gravity. There's another way through quantum physics. So, the quantum physics is simpler. I have less there, so I'll do that first. Vibration, that sound is so much more complicated.